Hi, students. Let's look at this question here, which is on vectors taken from the year 1987, paper 1, question 18. So given ABCD have position vectors of ABCD given by these coordinates here, the column vectors here. So the vectors here. So the point P lies on AB, produce such that AP is twice of AB. Use the point Q, and the point Q is the midpoint of AC. Okay, great. So show that PQ is perpendicular to AQ. Okay, I think the first thing is to understand how P is produced from the line AB. So I don't really like it in this form. I usually will just ask students to change it to a ratio form. So AP equals to 2AB. Don't really like that. It's very easy to get confused. So really as AP over AB is equals to 2. Okay, this is much easier. So from here, what you need to understand is this is just 2 over 1. So AP is 2, AB is 1. So in this case here, if you have AB, then P is a point. P lies on AB produce, so AB produce, AP is 2. Then it's midpoint as well. So this is P here. So this is 1. Then this guy here is 2. Okay, so this guy will just be 1. So from here is no surprise. To find OP, what we need to do is just use ratio theorem. So by using ratio theorem, you know that OB is a midpoint. So hence by ratio theorem, OB is the middle guy, B. This is A. And this will be my P, right? Remember that ratio theorem, the middle guy is always subject. So B is equals to A multiplied by 1. So A plus P cross multiply. So you just multiply the ratio across, then add the ratio 1 plus 1 will be 2. Okay, so it shouldn't be an issue. So P will just be 2A minus 2A. So that's my P. So I'm going to just use 2. B was given by 1, 2, 2. Minus of A is 1, 2, 3. Okay, that will be 2, 2, 4 minus 3 is 1. Wait. So this is my OP. Now I'm gonna find OPQ. Q is the midpoint of AC. So similarly, I think it's just another midpoint. So I'm gonna just draw it out. Scale will be AC. This is Q. That will be 1:1. So shouldn't be the issue here. OQ, OC. Similarly, by ratio theorem, we know that by ratio theorem, we know that OQ, which is Q, is given by A plus C divided by 2. Okay, then what we're gonna do is just sum it. A will be given by 1, 2, 3. B is 1, 2, 2. And C is 3, 2, 1. So C is 3, 2, 1. So half. A will be 1, 2, 3 plus 3, 2, 1. Just sum them up. Q is just 4, 4, 4. There you go. Then Q, no, half of 4, 4, 4. So this case still I'll get is 2, 2, 2. Okay. So OP and OQ. So this is a good question because if I'm able to show that they're perpendicular, likely my answer is correct for the coordinates of OP and OQ. So finding OP. So if you want to show that perpendicular, want to show that the dot product is 0. Okay, so that's the main thing. We just need to show that this is 0. So I'm going to find PQ first. PQ will just be OQ minus OP. That will be 2, 2, 2 minus 1, 2, 1. That will be 1, 0, 1. Then after which we have AQ. AQ similarly is OQ minus OA. So OQ is 2, 2, 2 minus of OA. OA is 1, 2, 3. That will be 1, 0, negative 1. Okay, it seems like it. So hence, you take PQ, dot with AQ, the dot product. The dot product will be 1, 0, 1, dot with 1, 0, minus 1. 1 plus 0 minus 1 is 0. So since PQ dot AQ equals 0, hence PQ is perpendicular to AQ. That's it. Okay. Finding an area of triangle APQ shouldn't be an issue. So what we need to do is part 2. Just APQ, just take any two adjacent triangle. So APQ, two adjacent sides. So we can just area of triangle APQ. Because we have all the coordinates on the column vectors of each of the vector, right? So what we could do is just half AQ cross AP, or you could take half PA cross PQ, or you could just take half QA, all of which will give you the same value answer actually. All right, so either one will do, but it's just half AB sine C in disguise. Okay, just remember that. This is just cross product. Yeah. Then what we do, I'm gonna take AQ cross AP. I have my AQ, right? My AQ, do I have my PQ? AQ. The interesting thing about this is because this is 90 degrees, so essentially we don't really need to use this because PQ is perpendicular to AQ, meaning this is 90 degrees here. Okay, let me just redraw this. So you could proceed by using this, but it's redundant now because from the previous part, I know that that this is 90 degrees. So in this special case here, what I'm going to do is half. You could actually do any of this, it's fine. AQ QP, half multiplied by base multiplied by height. Okay, so we have AQ. AQ is 1 0 minus 1. QP, do we have it? QP, yeah, there you go. Is or just PQ. PQ. So hence this area of triangle APQ. Half multiplied by base. AQ is 1 0 negative 1. PQ is 1 0 1. That will be half square root 1 square plus 0 square plus 1 square. That will be square root 2 square root 2, then there will be 1 square units. Alright, there you go. Let's look at part 3. Part 3 should be quite relatively easy. Vector perpendicular to the plane ABC. Alright, so if you want to find the vector perpendicular to plane ABC, just cross them. Find the normal, find a vector perpendicular plane. So you just cross them, part 3. We have A here, B here, and C here. What we want is, if you want the normal, what you do is you take AC, cross with AB. Okay, you get the normal perpendicular to both vectors there. So hence vector perpendicular to plane ABC will just be AB cross AC. That's about it. So we have what are the coordinates, right? The coordinates are written nicely. So this will be OB minus OA as usual, cross with OC minus OA. Great. Then we'll just do that. OB will be 1 2 2 minus OA 1 2 3 cross with AC, which is actually 3 2 1 cross with minus of 1 2 3. There you go. So this case here, with a cross stitch will be quite okay. I think cover this up with 0 here, then cover this will be 0 negative 2 and 0. Okay, so this case here, I'm going to divide by negative half, so it's 1 0 1 0. Okay, so hence a vector would be zero, 1, 0. Actually, is parallel to the y-axis. Okay. Finding the cosine angle of AD, between AD and BD. So just use dot product. That's about it. Cosine angle. Use dot product. So this case here, do not find the acute angle. Just find the cosine angle. So you just use normal dot product without the modular sign on both sides. So it's ABBD is equals to mod AD mod BD cosine theta. Okay, so let angle between AD and BD be theta. Alright, so similarly, I'm gonna find AD first, then AD should be quite okay, right? So just put this. So for AD is OD minus OA. Then BD is BD OD minus OB. So I think finding AD and BD, they are pretty okay. So just replace, substitute it in. BD will just be 3, negative 3, negative 3. Then just, this is just minus 3, minus 4. 3 minus 3 minus 3 cosine theta. Okay, dot this will be not 3 multiplied by 3, which is 9. Minus 3 multiplied by minus 3 will be 9. Minus 4 multiplied by minus 3 will be plus 12. So it's dot product. Then this case here, previously I make a mistake here. That's why a sudden shift in the screen. This will be 3 square plus minus 3 square plus 4 minus 4 square, not 9, okay. Root 9 there will be plus minus 3 square plus minus 3 square. So what we're going to do here is to just key in calculator. 30 equals to square root 34, and after which 9 plus 9 plus 9 will be 27 cosine theta. We need to find the cosine theta there. So cosine theta will just be 30 over 34 multiplied by 27. Of course, we can simplify this. So 34 could be divided by 2. That would be 27 could be divided by 9. So 2. I think we can't further simplify 2 multiplied by 17 multiplied by 3. So I'm gonna just bring the 3 out to be 2 multiplied by 7 multiplied by 3 here. 30 root 9, which is perfect square. There will be a 3. So 2 multiplied by 7 multiplied by 3, that will be 102. So hence, this will be 10 over root 102. Okay, so that's how you do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.